Welcome back. All right. Geologic time. There's two different ways to look at it: absolute dating and relative dating. So let's focus on relative dating for this section. There are six fundamental principles that are used when trying to kind of relatively date things to say this is older than that, this is younger than that. We'll go through all of these. There's the principle of superposition, principle of original horizontality, principle of lateral continuity, the principle of cross-cutting relationships, principle of inclusions, and the principle of fossil successions. Now, these principles of stratigraphy were developed in the 17th to 19th centuries. That's the 1600s to the 1800s. By the work of such famous geologists of Nicholas Steno, he kind of came up with the first three. James Hutton, whose name you'll hear come up a number of times, he kind of came up with cross-cutting relationships. William Smith, who developed the first geologic map, which we looked at examples of geologic maps in Lab 3, amongst many others. So, what do these six principles look like in reality, and how can we date things relatively? Let me move me somewhere. Let me move me up here, so I'm not covering any words. All right. So the principle of superposition states that if we're looking at some undisturbed layers of sedimentary rock, then the oldest layers are at the bottom and the youngest layers are at the top. For example, if I start to stack these boxes, all right, 1, 2, 3, all right, which one appeared first? Well, the bottom one. So which one's been around the longest in this pile? The bottom one. Well, kind of the same thing with rocks. If these are undisturbed, then what we'd be looking at is the oldest layer of sedimentary rocks are at the bottom, youngest are at the top. That's the principle of superposition. What we see over here is kind of, sometimes they're called stratigraphic sequences. They're like little puzzles in which we're trying to kind of put in order the events that we see in a particular cross-section of Earth. So just like in reality, where the oldest stuff is at the bottom, the youngest stuff is at top, or maybe over here, the youngest stuff is at the bottom, the oldest stuff is at the top. But on the bottom, we actually have a couple of things going on. So we'll come back to that. So anyway, principle of superposition. You go to the Grand Canyon. Where's the oldest rocks? At the bottom. Where are the youngest rocks? Up top. Easy enough. The principle of original horizontality states that sediment and the sedimentary layers is initially deposited in horizontal layers. Therefore, if we're looking at sedimentary rock layers that is inclined from horizontal, that tilting must have happened after deposition and lithification, after that material turned to rock. All right, so originally, sediment and sedimentary layers are horizontal. If they're tilted, that happened at a later time. That came later. So we can assess that these sediment was deposited first horizontally, then the rocks formed, then all of that stuff was tilted up. That's what we can assess there. That's not really shown in this stratigraphic sequence over here, other than these are originally horizontal. The principle of lateral continuity. Lateral means sideways. So what this states is that sediment was deposited in kind of continuous lateral sideways layers in all directions, kind of continuously, until it kind of pinches out or is kind of bounded by a basin or mountain ranges. And if the sediment is continuous, then the rock layers that form from them have to be continuous. So this is again looking at the Grand Canyon. So obviously there's a big canyon here. So what the principle of lateral continuity is saying is that this rock is the same at this rock. At one point, these had to be continuous. This layer had to be continuous. It didn't form on this side and then magically also form on that side. No, it formed continuously. Same with this layer down here. Same rock here, same rock here. That had to be continuous. So when you're at the Grand Canyon, you can look across and kind of match up these layers. Initially, the Grand Canyon area was just all flat. A river later came through and caused the weathering and erosions, the Colorado River. So it didn't form like that. It wasn't just a canyon all of a sudden. flat continuous layers. These are sedimentary rocks. Do you remember that story? Most sedimentary rocks are due to sediment deposited in the shallows of the ocean, which is definitely what we see happening in the Grand Canyon. Limestones, sandstones, and shales, all of these deposited in shallows of the ocean as they kind of creep into an area and leave an area, and that's what we see a number of times in the Grand Canyon. So this was just flat sediment until the river came down and cut through it. These layers were continuous. Principle of cross-cutting. An igneous intrusion, so hot magma cutting its way through some rock layers, or faults. Faults we briefly touched on, but that's an area where there's break and movement of earth material. Those intrusions or faults must be younger than the rocks it intrudes through or displaces, that it moves. So the rocks had to be there first in order for these to cut through them. Stupid analogy alert. This always reminds me of the Kool-Aid Man. I don't know if you're old enough to remember the Kool-Aid Man commercials, but they're like kids sitting in the house, like, oh man, I wish I had some Kool-Aid. And then the Kool-Aid Man, this big red bulbous character, breaks through the walls, and he's like, oh yeah! He just breaks in your house. That's kind of what I think of. So the wall had to be there first in order for the Kool-Aid Man to break through it. These existing rocks had to be here first in order for these igneous intrusions to cut through it. These sedimentary rock layers had to be here first before they could be broken and faulted, before these faults could kind of cut through here. So when we're looking at this kind of stuff, so the original rock is the oldest of them all, and then we have actually two different intrusions. So this is younger and this is youngest, because this black one is younger than everything because it cuts through this kind of gray rock and this white intrusion. So it's got to be the youngest of all. Both of those had to be here first for this black layer to cut through. And then again, with the sedimentary rocks, these layers had to be older and this fault has to be younger. These layers had to be here first in order for this break and movement to develop. Okay? So looking at this stratigraphic sequence, right, in order for what this looks like some sort of magma intrusion like we see here, these layers had to be there first in order for this to kind of start to cut through. All right? Kind of just knowing that, you can start to put these stratigraphic sequences in order from oldest to youngest. It might be something like using superposition, B, C, D, E, and then A cuts through. It's kind of hard to tell with the last two. So A cuts through B, C, and D. So B, C, and D had to be there first. So B, C, and D. And then A could have cut through and it stopped. And then E was deposited on top. So it could go B, C, D, A, E. Or all of those could have been there first and then A comes in. So B, C, D, E, A. We would need more information to kind of get a correct answer there. All right, let me move me back, I think. So superposition. All right, G is the oldest, A is the youngest. This is lateral continuity. These were once continuous. Original horizontality. These layers were horizontal before they were tilted. Principle of cross-cutting. All of these layers had to exist first before what looks like this hot magma could cut through these layers. Some additional principles. The principle... Oh, I gotta move me back again. Principle of inclusions. What this states is that rock fragments that are included in or enclosed by other rocks are older than the enclosing rocks. So this piece had to exist first, so it's older in order to exist in this rock. This rock, if we look at the stories of rocks, it looks vesicular, it looks volcanic, maybe scoria or something like that. So it looks like this rock existed, and maybe this lava, this is an extrusive igneous rock, kind of flowed out around this rock. So this rock existed first, this material cooled, so older, younger. Same thing here. This is very different than the rock surrounding it. So this is older, and this rock is younger. That had to exist first in order for this other rock to form around it. So in stratigraphic sequences, we kind of see this. So what it's saying here is that this green layer, which is down here, pieces of it are broken and then included in this orange layer. So these pieces, the pieces are older than the rock that encloses it. So this is older than that. But we also know that from superposition because it's below here. One more, and we'll talk more about this later in the semester, but the principle of fossil succession. It's kind of to the point that fossils found during a certain time are unique. We only find these certain fossils at a certain time, and fossils evolve. We see evolution in fossils. Organisms evolve, so the fossils in different ages have progressed and changed as time has moved forward. So, when we look at fossils, which is another unit we'll come to here shortly, I believe it's next unit, if you find a rock with a particular fossil in it, that rock is of a particular age. You don't even have to radiometric date it because we have, certain ideas of when, for instance, this pink ammonite fossil existed. So if I find a rock with an ammonite, we can kind of narrow it down to maybe a particular relative age or on the geologic scale, but also an absolute age. So let's go ahead and pause there. So this is relative dating, and as it's driven by kind of the 6 major principles of stratigraphy. But here's the thing with those 6 principles of stratigraphy. Sometimes weird things happen. Sometimes weird things happen, and we have to interpret that when we're looking at the sequence of events to try and figure out what happened, what's the oldest, what's the youngest, what's the order of events. Sometimes weird things happen, and those weird things are called unconformities. We'll pause here, and when we'll come back, let's talk about some weird things. I'll see you back here in just a second.